Hello everyone, today I'm going to be showing you how I made a simple alarm, but with a twist that we haven't seen on my channel before. I did it without using any coding. Let's see how I did it. This is a 555 timer. It's an electronic oscillator, which means it can set things high or low on a set frequency of time. If you hook it up to some capacitors and resistors correctly, you can accomplish an alarm clock, like the video I have here. Let's look at a schematic of it. So the first pin is ground, the 5th and 8th pins are both voltage. Then we have the trigger and threshold pins. Trigger detects low voltage, threshold detects high voltage. These values are then put through the internal workings of the timer and then output through the output pin. You also have the reset pin, which is used to reset the flip-flop back to the start of the cycle of turning on and off. Then you have the discharge, which is used to physically set the timer back to ground when the trigger detects low voltage, and to flip it off of ground when the threshold is used. These are capacitors. They store electrical energy for a short period of time. And basically how they work is that they have two plates and a dielectric material in between. And this allows it to store up charge and then release it as needed. There are two types of capacitors that I have here. This is a disc capacitor, which is ceramic, and it's also non-polar. These ones are electrolytic capacitors, and they are polar capacitors. Non-polar means that the side you plug it in doesn't matter. They will operate the same. Whereas the electrolytic ones, they're polar, which means the longer side has to be plugged into power and the shorter side has to be plugged into ground. If you don't do this correctly, they may explode. Disc capacitors are better for general usage, and electrolytic capacitors are better for high power or high power consumption uses. Here's a little demo of the project. You see how the light is lighting up and the buzzer is buzzing at a set frequency of time, just like I explained with the 555 timer. And what's great about this project is if I disconnect the capacitor for a second and I put in a smaller capacitor, 1 second right here, you can see the frequency goes way up. This is because the capacitor is smaller and it's able to accumulate charge and discharge it at a faster frequency because it is smaller. Now, how does this project really work? Right? It may seem quite complicated with the new components and whatnot. So let me go through the cycle. First, we start with the button and LED off, and the capacitor is currently charging. Once the capacitor charges up, the trigger pin detects low voltage because the capacitor is essentially taking voltage from the timer, and the trigger pin detects low voltage. Then it sends it through to the output, and the capacitor discharges because of that. The output is now high as well. The button and LED turn on with the voltage coming to it now, and the timer starts taking that voltage from the capacitor. That's glossing over what actually happens, but that's the easiest way to explain it. Once that timer takes all that voltage and the capacitor is left with nothing, the threshold pin is able to detect high voltage, and this sends an output to the output pin, which then turns the output low. And then the cycle restarts with the button and LED off and the capacitor charging once again. And this is where that 555 timer is used, because it allows it to restart that cycle over and over and over. So if we come back here, that whole cycle that I just described is happening within fractions of a second. That's how fast these timers can work, and they can work even faster as well, because as I showed before with the changing of the capacitors, different values of capacitors can change how fast, how the frequency of the timer operates. And so can these resistors right here, right? And also this disc capacitor right here. All of them, if you change the values to be lower or higher, affect how the timer works and how it outputs things to, how it outputs signals to the LED and the buzzer. So why is this type of circuit important? Well, it might seem not useful right now, but we use this all the time. If we had to code in everything, all of our circuits that we did, we had to input code, that would require a microcontroller to be present at every electronic circuit. That's not possible, right? And we can make these types of circuits a little more complicated, but all we need for them is power and ground. That's the only thing I have linked up on this Arduino over here. And that's why they're important. We don't need a microcontroller to power this circuit. It can power just fine with just 5 volts and ground. And that's what makes it so power efficient and removes a lot of the hassle of coding and inputting a microcontroller into any circuit. And that's pretty much how battery powered things work. You put a battery in, all it does is complete the circuit between 5 volts and ground, and then your circuit works as intended. You don't need a microcontroller to make all of this work. Though it may simplify the electronics part, it requires that there be a microcontroller at all places, which is certainly not possible. Alright, thank you guys so much for watching this video. I hope you liked it. Please subscribe to my channel if you want to check out more. Don't forget to check out the shorts page on my channel, which has a lot of Arduino tutorials and demonstrations that you can look at if you want a quicker overview of what I really do. Thank you so much once again, and I'll see you in the next one.